Hi, welcome back. In this video, we're going to talk about how parallel lines have anything to do with proportions. Okay? If you have not subscribed yet, go ahead and do so right now so you can keep watching more videos anytime that you're out, or would you like more explanation of what we cover in class? If at any point you find anything in here that is useful to you, that makes sense, click the like button. All right, everyone, let's get started. So first we're going to look at this triangle that is composed of two parallel lines. These pink arrows that you see here represent parallel. So I know that line ST and RQ are parallel. The first thing that I'm going to look at is I'm going to start labeling my triangle with the given information. Okay, so I have PT is 7.5. TQ is equal to 3. SR is 2.5. And I'm trying to find the length of PS, so I'm going to label that as X. Now, because we're dealing with parallel lines, what ends up happening is that there's a line here. These parallel lines make these separate parts of the triangle proportional to each other. So you have the top part of the triangle, this like peak area, is going to be proportional to this bottom area. Because the lines are parallel, it means that they're equidistant from one another. So they can create a proportion. And what I like to do is I like to just take the line, the parallel line itself, and just treat that as my fraction. So then I can have the ratio of x over 2.5 will equal the ratio of 7.5 over 3. And now that I have my ratios, I can just solve. I can cross multiply and solve for x. So when you multiply the x and the 3 right across from each other, 3 times x, you get 3x. And then when you multiply the 2.5 times 7.5, you get 18.75. Let me check that real quick. Yeah, we get 18.75. And then to solve for x, we divide both sides by 3. X equals 6.25. And we were able to find that out because of these parallel lines that we have right here. It makes the top and the bottom proportional to each other. This next theorem is called the Midsegment Theorem. What it's talking about here, midsegment says that it's cutting the segments in half or into two equal pieces. So here I can tell that XY and XZ are midsegments. So I'm going to go in the triangle and I can see that this is going to be congruent to each other. Right, if you look at XY is cutting this line in half, and XZ is cutting ST in half. So I have these congruent pieces, and these two are congruent to each other. Okay, now what I'm trying to figure out here is I'm trying to figure out the length of XZ and the length of XY. I'm going to start with the length of, ST. Let's start with the length of ST. I want to figure out what the length is over here. Now, because all of the segments are going to get cut in half, I know that the ratio of these triangles is half. I'm going to highlight the two triangles that I'm looking at. I'm looking at this triangle, and because it's being cut, the segments are going to get cut in half, I'm also looking at this triangle that you see here. I'll put it in. So that small triangle is going to be half of the other triangle because the segments here get cut in half. So if I know that this length right here is 7, all I have to do to find ST is I multiply it times 2. I double it because this will be half of this. So 7 times 2 is 14. Now, similarly, if I'm looking at the other part of the triangle now, let's see. Now I want to focus on xz. So I'm looking at figuring out what that length is going to be. Okay, now I have two triangles here. I have this triangle here in the top, and then the overall triangle in this direction, the big one. Also, because we're dealing with midsegments, it's going to be half. So now we're dealing with 13 being here. The corresponding side will be half of the 13, which gives us 6.5. The key word here is midsegments. It's cutting the segments in half. So the ratio of all of the sides of these triangles will always be 1/2. So if you're given a small number and you're trying to find the big one, you multiply it times 2. If you're given in this other scenario, the big side, and you're trying to find the small side, you're just going to take it and cut it in half. All right, let's talk more about parallel lines. So here we have 3 sets of parallel lines. What this does, right, is that a way to think about this is you can really just see this as an extension. We can really just extend these lines and think of it as a triangle, if we wanted. That's supposed to be a big triangle, right? Now, again, as we said earlier, the parallel lines in a triangle makes these parts proportional. So what it means is I'm going to draw a line here in the middle that separates it, right? The numbers on the left of that line will be proportional to the numbers on the right of that line. So I can say the ratio of this to this will equal the ratio of this to this. I also just treat the line as my fraction, but now my fraction is vertical, right? So my setup is 5x over 3x will equal x plus 12 over 12. There's my ratio. Parallel lines makes things proportional to each other. It gives them the same ratio. Because if you think about it, the distance from this first line to the second one, that distance will be proportional to this distance. These are going to be equal in length, and these are going to be equal in length. So when you divide them, you have the same proportion. And now we just cross multiply and solve for x, right? As we've been talking about. So you cross multiply here, you get 12x. 12 times 5, you get 60x, equals, so if you cross multiply at the other side, we have 3x times this piece. As you cross multiply, you have 3x, let me go back. 3x times x plus 12. Now, because we're multiplying two terms, we have to distribute, right? So we have 60x equals, when you distribute, you have 3x squared. You multiply 3 times 12, you get 36x. Okay? And then at this point, to combine like terms, we move the 60x to the other side by subtracting 60x. 0 equals 3x squared minus, 24x? Now, if you remember from Algebra 2 and how to factor quadratics and how to factor them, you can factor out an x of both of these terms. These two have an x in common. Okay? So to solve, you factor out an x. X times something will give you 3x squared. You're basically doing the opposite of distributive property. And that's x times 3x. Right? X times 3x is 3x squared. X times what is going to give you negative 24x, the minus 24. And this equals 0. I wasn't intending for this problem to be an Algebra 2 review, but we ended up having an x squared in the process, so we have to solve. Then what you do, if you remember back to Algebra 2, we have these two terms. You set both of them equal to 0, and you solve for x. So you have x equals 0, and 3x minus 24 equals 0. And then we just solve for x. We've already solved for it here, but if you move the 24 over, right, you have 3x equals 24. Divide both sides by 3. X equals 8. So this one results in two possible answers, x equals 0 and x equals 8. As long as you know how to set up the proportion, that this divided by this equals this over this, we should be okay. We shouldn't be dealing with too many examples where you have to do quadratics and x squares and factoring. It'll just be a very simple solve for x kind of situation. But if you do get an x squared, then we know that we have to go back to our Algebra 2 concepts of how to factor and how to solve for x squared. All right, last example. Here we have another set of parallel lines. So I know if I look at if I use my fraction as this line as a fraction, right? The ratio of the left to the right will equal the ratio of the left to the right. The thing is, if I were to set up this problem, I would have 6x minus 5 is to 4x plus 3, right? These two, the ratio of those two will equal the ratio of these two. The only thing here is that I cannot solve this problem by cross multiplying because I have two variables. What's going to happen when we multiply x times y and x times y? Like, we can't really solve for two variables at the same time. So I need to solve for one of these variables first. If I look at my stuff here, I can see that there's two tick marks in place. These two tick marks, right here and right here, means that these two are actually equal. So I can solve a problem separately, and I'm going to do this in a different color. I can solve 3y plus 8 equals 5y minus 7. Those two segments are equal. So I don't need a proportion for that. I just solve by setting them equal to each other. That's what it means with having congruent parts in parallel lines. So as I solve for y, I subtract 3y on both sides. 8 equals 2y minus 7. You move the 7 over. 2y equals 15. Divide both sides by 2. Y equals 7.5. Now I can use that 7.5 and plug it in here. Right? If you plug it in there, you're going to have 3 times 7.5. This is really just 3 times 7.5 plus 8. And the bottom is 5 times 7.5 minus 7. So what happens when I plug it in is that I'm going to be left with, let's see, 30.5, I believe. 3 times 7.5 equals 22.5 plus 8 is 30.5. So on the left side, I have 6x minus 5 over 4x plus 3. Equals, the right side, I simplify it, I get 30.5 over 30.5. Right? So, now that I only have one variable, I can cross multiply and solve for x. It seems like I'm running out of space here, so let me clean some stuff up. So as I cross multiply, I have 6x minus 5 times 30.5 equals the other side. We cross multiply. 4x plus 3. I probably should do this in a different color so you can see it separately. Things are just getting a little bit messy here. I'm sorry. If you know how to solve this proportion, feel free to like log off. I just want to make sure I show you how to follow through the whole thing. The biggest thing here is, do you know how to set up a proportion? Right, I have 30.5 times 6x minus 5. And on the other side, when you cross multiply, you have 30.5 times 4x plus 3. So we distribute, and we just continue solving for x. This just happens to be a decimal, so it gets a little bit messy, but 30.5 times 6x is 183x, minus 30.5 times negative 5 is negative 152.5. On the right side, we distribute more, right? We have 30.5 times 4x, which is 122x. And then 30.5 times the 3 gives you positive 91.5. It's still solving for x, I just have to deal with some decimals here, right? So I'm going to combine like terms. I'm going to subtract the 122x on both sides to combine the x's. Right? We have 183 minus 122. We get 61x minus 152.5 equals 91.5. We move the negative 152 to the other side, so we do the opposite. (6x) equals 91.5 plus 152.5 is 244. Divide both sides by 6. We're finally at whole numbers. And then it brings us back to decimals. Which is 40.66666. So x equals 40.67. This one was a bit messy. Sorry about that. The thing to consider from all of this, it can be very intimidating, is that when you have congruent pieces, you set those equal to each other first. You set them equal to each other. You solve for the variable. Once you solve and you plug it in here, then you can just set up your proportion. Some proportions are messier than others. Some of them have nice whole numbers, like in this one. Sometimes you have decimals and then you get some weird results. But in the end, you're still setting up a proportion from this side is to this side, as this side is to this side. You just have to find y first. All right. Let me know if you have any questions by commenting below. I hope this has helped you a little bit. And as always, we'll calculate later.